Aloha, Rich Alverson here. This is ICS211. And in this video, I'm going to go over lab 7.26, which is check if the array is sorted. So let me share my screen. All right, in this video, in this assignment, all we got to do is we got to write this in order method. And all it does is it traverses an array of integers to see if there's anything out of order. So basically, it returns true if they're in order, if it's all sorted, and it returns false if it's not. So basically, the way we're going to do this is see 5, 6, 7, 8, 3 is not in order, so it displays this. 5, 6, 7, 8, 9, 8, 10 is in order, so it displays this. And so the approach that we can take, and then we just write our code here. And this does the test. This is going to test the out of order one. This is going to test the in. Okay, so the approach that we can take is to just start with one of them, and then check to see if the next one's got to be the same or bigger. Okay, and then go to the next one, and so as you traverse up the array where you're at, the next one has got to be the same or bigger. And then if that's true all the way up to the top, then we know that it's in order. If there's ever a time when the next one is smaller than the next one is smaller than the current one, then we know it's out of order. And in fact, if we just as soon as we see that, then we can just return that it's false. So the worst case, best case scenario for determining if something is in order is O of n, and the best case for finding out if something is not in order would be O of 1, because if the second element is lower than the first one, then we know right away that that's not in order. All right, so let's start writing our code. Let's see, we can do a 4 nums is what we're looking at. It's an array of integers, so 4 int, this we can use I, equals. Now, we only when we traverse, we're going to traverse steps. The number of incrementing steps is going to be 1 less the number of elements, because when we're at the first one, we're looking at the second one, and when we're at the last one, we're done. Okay, if we're at the last one, there's no 1 after that. So we actually only have to go up to n, from 0 to n to the index, to the upper index minus 1. So we can start at 0, or we can start at 1. I less than or equal to nums. Oh, less than, definitely nums, length. So this should look at every single one, but we want 1 less than that. So it goes 0 to 1 because you don't count the dominant. So we want 1 less than that, and then we can do I plus plus. And what we're going to be doing is if nums of I is no, let's do it the way we said it. If nums of I plus 1 is less than nums of I. If that's true, if it's true that the one after this one is less than, it can be equal, it's less than, then we're just going to return false and be pow. Okay. If we make it all the way through that for loop and we come out the other end, then we know it's in order, so we return true. Okay. All right, so let's try. Oh, I guess we can just try stuff. All right, well, I'm going to go ahead and try this one. No, it gives you, no, wait, we aren't going to, it's defined in there already. Well, okay, I'm just going to run this and see what happens. Okay, it expected a semicolon right here. Separating that. So that's a syntax error. I don't know what language I was thinking when I did that. That's it, right? Okay, well, I'm pretty sure that this is correct. So I'm going to let you confirm that. Thanks for watching.